Hello guys, welcome you guys again for this end-to-end session on AML. It's gonna be a year-long program. Hope you guys are enjoying the session. So today we're gonna see the continuation of previous session. Like previous section, we have just explored what is EDA. So today we're gonna just explore the continuation of it. So what is the first thing is that what we're gonna do means we're gonna see about detecting outliers and anomaly. So like I think we have mentioned this what is anomaly and what is outlier in this two classes before. Like why we just need to remove that. Okay, actually because like outlier is something which is out of the box of normal data that we are having, and anomaly is like somewhat near to it. So how we can handle this? Statistical methods like Z-score, interquartile range, like those things is used to find the outliers or anomaly. So and then visual inspection like scatterplot, boxplot, and histogram are very helpful in finding these outliers and anomaly. Whereas for domain experts, okay, whenever you are going to find the like outliers and anomaly to the data set, you need to go for a proper domain expert who have the better understanding of the data. So, leveraging a knowledge of specific domain to identify the outliers that may be meaningful or required for further investigation. So, this is all about whenever how you can find the outliers and anomaly. Yes, sir. Over to you.
Yes. So detecting outliers and anomalies, again, we are reiterating, guys, only come to this session after you complete all the sessions 5 to 10 times, absorb the information and digest the information and then apply. So first, concept clarity is very, very important. That is why before going to application, we are explaining each and every concept very deeply with analogy and examples and our experience. So write in the comment section what have you learned, how you're going to apply, what and give us feedback so that we can keep improving these sessions continuously. So outliers and anomalies can be significantly they affect the data analysis. So detecting them allows us to investigate their causes and decide whether to remove them or adjust them accordingly. So we have to do detection of outliers and anomalies. So statistical methods are used to detect, like we use technique like Z-score, IQR to identify data points and uh, significant from the expected range. So we use all this statistical method using Z-score and IQR to identify outliers and anomalies, and data inspection, examining the scattered plot, box plot, and histogram, and visualizing identify data points that appear unusual, like which, suppose I've given example previously also. Suppose you have a data range house costing $20,000, $30,000, $40,000, $50,000, and then you have data here 15,000, 10,000, uh, around 20,000. So range is 40 to 10. Okay. Now you have a data set which says 200,000, 500,000. So that is outlier. So there is some problem. So you will see through, if it is not following the central tendency, which is like your baseline. What is your baseline? Where is your data, maximum data scattered around? So from there, you need to see if something is abnormal, that's called anomaly or outlier. Okay, so with data visualization inspection, we use different methods and libraries, and we visualize the data and we detect the anomaly. Okay, domain expert. So expertise, people who are expertised in the domain. That's why data scientist has to work with domain experts also, because leveraging their knowledge on specific domain identifies outliers, because they know actually what are outliers in this industry. So it will also help you to meaningfully require further investigation, you will get a lot of insights from those people because they've spent 10, 20 years of experience. They know in and out that industry, and you may not know. So you will get a lot of experience and a lot of insights leveraging their knowledge, and you'll get insights, and then you use those insights in your project. Thank you. Let's go to the other slide.
Yeah, sure, sir. Actually, it's a great explanation. So this is what all about how we are able to find the outliers and anomalies. So next we're gonna see what is the relationship between variables. That is how to find the relationship between variables. So this is one of the important thing. Like in EDA, exploratory data analysis, we need to find the relationship between the variables, so then we can have a better understanding of these are the variables that we need to take in order to find the target value. So first is correlation analysis, where it is used to find the coefficient of quantity and strength and the direction in the linear relationship. Next, we are having scatter plot, as we are discussing. It is used to find the relationship between the two variables, and it is relating to the trend that we need to find. Okay. Next, next is something like we are having regression analysis, which is modeling the relationship between variable to understand the influence of one variable on another. So that is what the regression analysis. It is like it says what is the relationship between each variable with the other variable, so that we can find these are the variables that has a relationship between them, so that we need to use them in order to find the target value. So these are the different things that we are having in order to find these are the analysis, okay, of a relationship between the variable. So these are the different things that we use in order to find the relationship. Yes, sir, over to you.
Analyzing relationship between variables. Again, guys, in EDA, it is a very important tool which will help us to find how they are correlated, their relationship, and then we build predictive models around it. Okay, so correlation analysis helps us like calculating correlated coefficients to quantify the strength and direction of linear relationship between variables. So we have to see the linear relationship. What is in correlation analysis? We see linear relationship between variables. What is their relationship? Huh? So in scattered plot, again, we visualize the relationship between variables, revealing pattern, trends, and outliers. So we understand the behavior with the scattered plot. And regression analysis, we do modeling the relationship between variables to understand the influence of one variable on another. So we do regression analysis like you have, uh, suppose you have a coffee shop, you're selling coffee. You want to know the best price of your coffee. So what is the optimal coffee, and you sell maximum cup of coffee. Okay, what is the best price so that customer buys the coffee and you are profitable. So what you'll do is you'll try different prices. Suppose you try price at 90 rupees, you and you calculate that data for a week, or then you try a price at 150, 200, 250, 300, and then you see that how was the customer behavior, how when they purchased, and also see, we are talking about one variable on another, right? So costing, like buying number of cup of coffees, and also you are profitable. These are two variables for you. So when you collect data on different variables and then you compare and you see, oh, 150 is the best price and I sell the maximum number of coffees and I'm most profitable. So there you understand power of regression. I'm giving one example, guys. You can apply it to different. So when you do regression analysis, you understand that it's a very, very simple and but yet powerful tool. You can use these algorithms in normal life also, but you just need to know conceptually that how to use them and how to get insights and how to use them. That's very important. And conceptual clarity First you need to absorb and then digest and apply those concepts and models in real life. You can apply them, and then it will be very interesting and you will enjoy it. Thank you. Let's move to the other session.
Yeah, sure, sir. So next we gotta see a feature engineering section. Actually, we have seen this before. So we are gonna create something which is new by using the existing data that we are having in the data set. So first is feature transformation. Like we're gonna transform, create a new one based on the features existing transform. Okay, existing feature transformation so that we create a new feature. Okay, next is feature interaction. We're creating a new feature by combining existing features. So by combining the existing feature, if we create a new feature, then it is called as a feature interaction. Next, we are having feature selection. So feature importance score, a statistical test to find the relevant features for the model. So only relevant feature finding is called as a feature selection. So I will put it in this manner. Whenever you need to transform, simply transform the existing feature to a new feature, you need to go for feature transformation. If you guys need to go for feature interaction, then what you need to do means you need to just combine the existing ones, existing features so that you get the new feature. So new feature interaction. Feature selection means you need to find the relevant features based on some statistical or some kind of analysis through the scores. We can do this feature selection. So yeah, that's it from my side. How about this feature engineering and such? Yes, sir. Over to you.
Yeah. So feature engineering and selection. So first, why we use feature engineering and selection? It will guide us creating new. It will help us to create new features from the existing data. Keep it simple, huh? Just understand and absorb this much. Creating new features from the existing data. That's it. Feature selection helps us to identify most relevant features for the model. So we'll in feature selection we can remove certain features, but it should not impact the analysis. That's the important thing you need to remember. Keep it very simple. When you keep things simple, it is very good that you apply them in a simplicity and then you get results. So feature transformation is transforming existing features into new one, which I already mentioned, such as scaling, um, binning. We need to do bins and we encode categorical variable, encoding categorical variable. So this is how we transform. Okay, then we have feature interaction, creating new features by combining existing ones and capturing the interplay between variables. So we need to understand. You need to interplay with the variables. You need to know in and out about all the elements when you are doing feature engineering. So what are the variables? You need to know data in and out, okay? So then and only you can interplay between variables, huh? And then you know which one are useful, which one are not useful, which one I need to clean, which one I need to do, uh, on which one we need to do feature engineering, okay? Then we have feature selection. We use techniques like feature importance scores or statistical tests to identify most relevant features to build model. Then we have to select certain features, and then we uh, for for model building. So these are three things which you need to understand, that it is like in our, I'll give example of feature engineering is, in our DNA we have only four DNAs, yeah, components, but how many combinations are there? And you can see there are 7 billion people on planet earth, but nobody from the beginning until now, until infinity, you will not see a match. You'll never ever see the same fingerprints, and that is a very deep feature engineering which nature does. So, I'm saying only four DNA elements make so many features that from the beginning of life till end, no human being's fingerprints will be same. So understand the power of like even if you have three, four features, you can do miracle with that. So understand power of multiplication and the feature engineering. Okay, I just gave biotechnology example. So we can use AI, ML, data science anywhere. Wherever is data, wherever we can get data, we can do data science on it. Thank you. Let's move to the other sessions. Slide.
Yeah, yeah. Actually, sir has a great point. Wherever there is a data, we have a work. So that's a great point. Like, yeah, guys. Like as we are mentioning in the first session itself, data science is not a standalone field, or it is like a standalone batch or standalone subject like that. We need to learn data science, and we will try to apply this data science in some other field. So as I'm working as a data scientist in an embedded system company, so I need to know about the knowledge of this embedded system so that I can apply the data science onto it. So yeah, guys, so the thing is, data science is not standalone. It's gonna help every field. Okay, so moving on, we are having something called as conclusion and next step, guys. So first thing first, we need to document our findings. So whatever the EDA that we are having, we need to document it so that we can do the storytelling. I think now you guys have understand what is storytelling. Next is model selection. You guys need to select the model based on the EDA that we have done. So based on the EDA and based on its what is the outliers, anomaly, like those things, we need to select the model. Model validation. So you need to understand how the model is performing by using the EDA, because we already have an understanding of this is how the data is. Finally, deployment and monitoring. Like once everything is done, okay, all the EDA is done before and after. So you can go for a deployment and just monitor it periodically. So yeah, these are the conclusion that I hope you guys are able to understand these sample conclusion that we are having. So the end thing is like, in order to understand the data set very clearly, you need to go for EDA. Okay, so that is the key takeaway for you guys. So yes, sir, over to you.
Yes. So, conclusion and next steps, guys. Document the findings. That's very important. You have to build a report, that kind of with keep it keep it raw. Also keep it presentable so that it is authentic. So when it is raw, little raw, like take the screenshots of the findings, keep it as it is. Okay, and and keep, if you find some errors, keep it as it is and make a report. Find, make the include data characteristics, patterns, relation, take screenshots, put whatever coding you have done, whatever cleaning, you have to keep it as it is. And then you move it to model, model validation. Okay, model selection, sorry. So model selection, when you do based on EDA insights, select the most appropriate model for your data and task. So you can do research, that what are the existing projects, GitHub and other places, and see what kind of model they have used. And you also initial level. Later you will go deep into, you'll understand that what are the best models which have got the best performance. Then you do that, will help you. But later, once you gain experience, you will yourself select the model. Initially, you can take assistance. And then model validation, you have to select model using appropriate metric and technique to assess the performance. Okay, that's what you have to do when you're validating. You have to validate it as per your problem statement and other data characteristics and the techniques and all those things which you're using. Once you're validating, then you have to deploy and monitor. So you deploy the model to production and monitoring and performance. So you have to see the performance of it and continue performing and always keep improving. Okay. So like, yeah, sorry. Here we are not talking about that. Improvement will stop here. You have to deploy and monitor, and then yeah, it is at this stage. So you ensure that it continuously performs well as expected. So that's what it is. And this is, so keep, write us in the comment section what have you learned, how you're going to apply. First absorb the information, then digest the information, then apply, and do all the assignments and go and watch all the sessions 5 to 10 times so that you build muscle memory and not only your ears, eyes, but absorb through all your body atoms this information and make it intuitive so that when you go and apply, when somebody asks, when you do project, so you know not from your eyes and ears, but your body should know what are these steps, what are these models, what are these algorithms, okay? Whatever we are learning, so absorb it properly so that you will do it properly. Thank you.
Yeah, guys. Thank you, everyone. Like, we hope that you have guys have understand this. If you guys have any doubt, just put it in the comment. We are here to help you. So subscribe to our channel if you guys need to just follow this 1 year long program. Yeah, guys. That's it from our side. Like, thank you, guys. Thank you so much.
Thank you so much, guys. Keep learning and keep write to us in comment section. Subscribe to our channel and give us feedback so that we can improve each session, each. And we really respect you if you make some great projects and solve big problems and build your career, get job or a startup, whatever goals you have. Stay with us. We are going to help you, and this is service to humanity. So keep learning and give us feedback. And if you need any assistance, write to us at connect@nobletransformationhub.com so that we can help you. Thank you so much.